Hello students, and welcome to this lesson on finding the missing side of a right triangle. Our objective today is that we will apply trigonometric ratios to find missing sides using journal notes and practice problems. So let's first talk about our steps when we're going to be solving these problems. Step one is that we're going to label and identify the sides. You guys have already been doing that, right? Every time that you've looked at a problem, all that we've done is labeled and identified. Then you're going to choose the trig function that matches those labels. So you use your Sohcahtoa, right? And that will be your guide on which trig function you want to use. Step 3 is that we're going to set up the equation with the ratio. And then step 4 is that we're going to isolate the variable in exactly the same way that we would isolate a variable in our algebra problems. So let's start with our first example. So in example 1, we have a right triangle that has a 40-degree angle, and then it has two sides, one of which is 8 and one of which is x. So the side which is going to be touching my 40-degree angle is 8. So I'm going to call that the adjacent side. Then the side which is directly across from my 40-degree angle is my x. So that's going to be my opposite side. So from there, I look in Sohcahtoa, right? So sine requires opposite and hypotenuse. Well, I don't have the hypotenuse, so I can't use that. Cosine requires the adjacent and the hypotenuse. And again, I don't have the hypotenuse, so I can't use it. So I'm left with tangent. So I'm going to set up my problem as a tangent problem. So I can say that tangent of, remember that tan is a function, and it's a function of a degree. So tan of 40 is equal to opposite over adjacent sides. So my opposite side over my adjacent side. Or I can say x over 8. So let's go ahead and rewrite this as a single equation. So tangent of 40 is equal to x over 8. Well, now I want to isolate my variable. So I notice that x has something being done to it. Specifically, it's being divided by 8. And I know that in algebra, the opposite of division is multiplication. So to get rid of this 8, I'm going to say multiply by 8. So I'll multiply both sides by 8. So then I get 8 times the tangent of 40 is equal to x. So now my problem is almost solved. At this point, I can take out my graphing calculator, and making sure that I'm in degree mode, I can plug this directly into the calculator as is. So after I've plugged it into the calculator, I'll see that I have 8 times tangent 40, and 8 times tangent 40 becomes approximately 6.71. So my answer here is that x is equal to 6.71. So this side length here, this opposite side, is going to be 6.71 in length. Alright, now let's move on to example 2. So in example 2, I'm going to do the same thing. So I have a degree of 65, and then in relation to that, it looks like I have 6 is the hypotenuse, because this is directly across from the right angle, and then x is going to be the side that is opposite. So I have an opposite and I have a hypotenuse. So it looks like this is going to be a sine problem, because sine is opposite over hypotenuse. So then I can write out my problem as sine of 65 is equal to the ratio of x is my opposite side, so I say O over H, and then this is equal to x over 6. So I can now rewrite this as just an equation. So sine of 65 is equal to x over 6. And so then I can multiply both sides again by 6, and you get 6 sine of 65 is equal to x. At this point, I'm ready for the calculator again. So I say 6 multiplied by the sine of 65 degrees, and I get that x is approximately going to be 5.44. So not surprisingly, this is actually pretty easy, right? When they're set up like this, very easy for us to perform. All right, so now let's talk about problems that are not quite so easy. All right, so in example 3 and example 4, we have a similar setup, but we're going to see that there are some differences here. So example 3, we identify our sides as, well, it looks like the x is directly across from the right angle, so that's going to be my hypotenuse. And then 6.4 is going to be my adjacent side because it's touching right here. So I have an adjacent and I have a hypotenuse using Sohcahtoa, right? I'm going to use Sohcahtoa again. I see that adjacent and hypotenuse are going to be cosine. So I'm going to use this cosine here. So I can set it up as cosine of 70 degrees is equal to A over H. So now I just need to fill these in. My adjacent side is 6.4, and my hypotenuse is going to be x. Then I have cosine of 70 degrees is equal to 6.4 over x. Now here's where a lot of you will get confused, right? You see the x in the denominator, but this is going to be solved in the exact same way, right? So we want to get the x by itself. So the first step that I'm going to take is that I don't want this to be in the denominator. So what I'll do is I'll say multiply both sides by x. So I get x cosine of 70 is equal to 6.4. Now remember, cosine 70 is just some number, right? So I can say that this is just like having a coefficient on x. So what I want to do to both sides is I actually want to divide both sides by cosine of 70. So my next step is going to be that I'm going to divide both sides by the cosine of 70 degrees. And what I'll see is that the cosine 70, it's just some number, so it'll cancel out here. And you're left with x on this side, so you have x is equal to, and now you have 6.4 divided by the cosine of 70 degrees. And so this is just the division of two numbers, 6.4 divided by cosine of 70. So you have 6.4 divided by, and then in your calculator, input cosine of 70. And make sure you use your parentheses here. And what you'll see is that x is equal to approximately 18.71. So we just have one additional step in here, right? We had to multiply both sides by x and then divide by that cosine. Okay, so our last problem, we're going to do one more. We've got our angle here that we're working with, which is 42 degrees. And then we have our x, and our x is a segment which is touching 42 degrees. So that's going to be an adjacent side. And then 9 is going to be the opposite side. So I have O, I have A. It looks like I'm going to use tangent. So I write out tangent of 42 degrees is equal to opposite over adjacent. And then my opposite side is my 9, and my adjacent side is my x. So now I've got tangent of 42 is equal to 9 over x. I want to multiply both sides again by x, and I'll cancel out this x here, and that leaves me with x tan 42 is equal to 9. And now I want to divide both sides by that tangent of 42, because that's just a number. And what we'll see is that we get x is equal to 9 divided by the tangent of 42. and we can put this directly in our calculator. And what you should get is that it is approximately going to be 10.00. So x is approximately 10.00. All right, so now what I want you guys to do is that you're going to go into practice yourself. So we're going to do a little mini quiz. It's not going to be for grade, but I do want you guys to practice on this. So your reflection is that you're going to complete the assignment over solving for a missing side in trigonometric equations. If you have any questions, let me know, and have a wonderful day. Goodbye.